Hi, this is lesson 3.5, lines to prove theorems about triangles and to find measures of triangles. So first of all, I want to talk about a theorem that we have here. And it says, through a point not on a line, there is one and only one line parallel to the given line. There's exactly one line through point P that is parallel to L. So here's the thing. This is line L, this is point P. So what that's saying is there is only one line that will go through point P and also be parallel to line L. All right, so let's go to the next problem here. This is super important. Put a big old star by this. The sum of the measures of a triangle is 180. All right, so if you add the measure of angle A plus the measure of angle B plus the measure of angle C, they will always add up to 180, no matter what. It doesn't matter how big the triangle is, how small the triangle is, the sum of the measures of a triangle is 180. So remember that. You have to know that. That's super important, okay? And I bet you're thinking, well, I would like to see a proof of that. Hopefully you're thinking that way. Well, let me show you because it's a pretty cool proof. So we start out with a triangle, and we want to show that the measure of angle A and B and C, so angle B is also called angle 2, and angle C, that those three angles equal 180. The way that we prove that is first by using that theorem that we started out with. We are going to draw a line PR through point B that is parallel to AC. And we learned that there's exactly one line that you can draw through a point that would be parallel to another line. So we just went through point B and we drew a line. So the reason would be through a point, not on a line, there is one parallel line. Sorry, the writing is not the best here. So through a point, not on a line, there is one parallel line. All right, so the rest of them should be a little bit better, I hope. So then it says the measure of angle PBC and angle 3 are supplementary. Okay, so angle PBC is this right here. So this angle here plus this angle here, it's supplementary. Well, we know that because of the definition of a linear pair. Definition of a linear pair. Now, if they're supplementary, what do you know about them? Well, that the measure of angle PBC and the measure of angle 3 equals 180. So that is the definition of supplementary angles. Now we're going to go to this next step and we're going to say, well, what do we know about angle PBC? Well, that is made up of angle 1 plus the measure of angle 2. Angle PBC, the measure of angle PBC is equal to the measure of angle 1 plus the measure of angle 2. That is the angle addition postulate. All right, so now let's see here. Now we go to the saying that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. Well, how did we jump to that? Well, look right here. The measure of angle PBC plus the measure of angle 3 equals 180. Well, what do you know that angle PBC equals? It equals angle 1 and 2, the measures. So we just substituted that in for right here. Instead of writing measure angle PBC, we put in measure angle 1 plus measure angle 2. And then we wrote the rest of it, plus the measure of angle 3 equals 180. So that's substitution. Now we're trying to get to the point that the three angles, angle A, angle 2, and angle C, equal 180. So now watch this. This is neat. Let me erase some of this here. It says that angle 1 is congruent to angle A. Well, let's see. Let's try to figure that out. Angle 1 and angle A. Why would they be congruent? Well, let's look at the lines that form those. angle 1 and angle A are what? They're alternate interior angles. So the reason that we know that they're congruent is because of the alternate interior angles theorem. Then the measure of angle 3 and the measure of angle C. Let's look at that. Angle 3 and angle C are congruent. Well, let's draw this transversal. Those are also alternate interior angles. So now it says angle 1 and angle A are congruent, but the next step says measure angle 1 equals measure angle 3. Well, remember, if they are congruent, then the measures are equal. That is the definition of congruent angles. So lastly, what did we do? We took this statement right here, and instead of angle 1, we put in angle A. That's substitution. Instead of angle 3, measure angle 3, we put in measure angle C, because those are congruent. So lastly, we did substitution. So that's how you can prove that the measures, the interior angles of a triangle are equal to 180. The sum of the measures equal 180. Now let's use that to solve a problem like this. All right, so basically, guys, if you know any two angles of a triangle, I'm going to actually scooch up here just a hair. All right, let's say that this is 60 and this one is 90. What would this one be? Well, if you know two of them, then you can figure out the third, because what did the three have to add up to? 180. So 180 minus, you can add those together, 90 plus 60, or you can say minus 90 minus 60. To subtract both of those, you would get 30. Okay, so that's how we're going to use this. So now in a problem like this, what are the values of X and Y in the diagram? So now we have like three triangles. You have two little ones and then one large one, triangle ACB, and then the two little ones inside. So when you look at a problem like this, you would not want to start with this triangle right here because you only know one angle. So you wouldn't start there. You look for a triangle where there are three angles, or excuse me, two angles. So this one, this is 43 and this is 59. So 43 plus 59, that equals 102. So then you can figure out what angle X has to be. Angle X is 180 minus 102, so that would be 78. Okay, so the measure of angle X, or I should say angle ADB, is equal to 78. All right, and X equals 78. And now if you have to find Y right here, well, look at X and Y. X and Y are a linear pair, which means that X and Y have to add up to 180. So 180 minus 78, and that gives you 102. So Y equals 102. Okay, now it's not asking for Z, but we're going to find Z. So you have this angle Y is 102, this little angle is 49, so 102 plus 49 is 151. And you know that 49 plus 102 plus Z has to equal 180. So 180 minus 151 would be 29. So Z, the measure of angle Z, is equal to 29. And those are all degrees. See how we work that out? All right, a vocabulary word for you. An exterior angle of a polygon is an angle formed by the side of and an extension of an adjacent angle. So if you take this angle right here, okay, if you extend a side, this angle out here, so one of the sides plus the other side extended is called an exterior angle. All right, so like if you extend this side and then look at this side, this is an exterior angle. All right, And we would call the angles that are furthest away from it the remote angles. So angle 1 is exterior. This one is adjacent to it right here, this angle inside. But angle 2 and 3 would be remote in this problem. Okay, and next we have a theorem that says the measure of an exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. All right, now this is a theorem that is a lot of theorems I will tell you that you have to know, but this is one that you could get by without knowing in many cases. This is a nice to know theorem because it can save you time if you know it. But with a lot of problems, you can figure them out without this theorem. So let me show you why. So in this one, what is the measure of angle 1? Well, angle 1 is right here. So you can add the two remote angles. So that would be 80 plus 18. Which is 98. So the measure of angle 1 equals 98. Now, like I said before, let's say that you didn't remember that, but you know that the angles add up, the inside angles have to add up to 180. So what you could do is figure out, let me get another color here, figure out what this angle equals right here. So to do that, you would add the angles together. Let me get my calculator here just to make this a little quicker for me. So 80 plus 18 is 98. And then you're going to subtract, take 180 minus 98, and that is 82. So this angle right here is 82. Well, then you say, well, I know that this red dot angle and angle 1 have to equal 180. So if you take 180 minus 82, you end up with 98. So you could figure it out that way too. So there's two ways to do this one. Now this one, you need the measure of angle 2. So we have to say, okay, inside of the triangle, we only have two angles this time. However, you know that the 124 and the one next to it have to add up to 180. So take 180 minus 124 and you get 56. Well, now you know that the three inside have to add up to 180. So take 180 minus 56 minus 59, and what's left is 65. So the measure of angle 2 is equal to 65. That's how I would solve that problem. The other way you could do it is again using the remote interior angle, which says that the exterior angle is equal to the sum of the two interior, 59 plus measure angle 2. So then you would just subtract 59. And that would be 124 minus 59, 65. So you can get it either way. All right, this next problem. When radar tracks an object, the reflection of signals off the ground can result in clutter. Clutter causes a receiver to confuse the real object with its reflection, called a ghost. At the right, there's a radar receiver at point A. So point A, you have a radar receiver, an airplane at point B, an airplane at point B, and the airplane's ghost is at point D, right here. What is the value of X? So we want to figure out what this angle is right here. So this angle is 80 degrees, which would mean that this is 100. Okay, because 100 plus 80 is 180, and that's a linear pair. So we're going to take 100 plus 30, and that gives you 130. And you know that the three angles in a triangle add up to 180, so take 180 minus 130. So the measure of angle X equals 50. Okay, just one second. I have students texting me here. All right, so that is it for this lesson. Real quick, I want to do a couple problems here in the book. It says the ratio of the angles of an acute angle, the ratio of the angle measures of the acute angle in a right triangle is 1 to 2. So we are going to draw a picture. It is a right triangle, which means you have a 90-degree angle. Now, whenever you have problems, you guys, that say ratio, what you want to do is write those as 1x and 2x. Okay, so this angle and this angle, we're going to call 1x and 2x. So whenever there's a ratio problem, write 1x and 2x. That's because a ratio is when you take two numbers and you like write them as a fraction and you simplify them. The simplified form is the ratio, and when you simplify, you're dividing by some x value. Okay, so let me show you then what you do. So we have some options. You know that 1x plus 2x plus the 90-degree angle, all three angles add up to 180. So now you solve that. So then we subtract. So 3x equals 90. And if you divide by 3, x would equal 30. So if you plug that back in, 1 times 30, this angle's 30. And this angle would be 2 times 30, it would be 60. All right, so those are the angle measures. Now I just want to show you again. So 30 over 60, so the ratio of those is 30 to 60, which is the same as 30 over 60. And if you reduce that, that would be 1/2, which is 1 to 2, because you can divide out a 10 out of each of them. So that's what we mean by ratios. All right, so let me know if you have questions with this assignment. Thanks for watching.